Let's work some problems taking polar coordinates and plotting them and then converting them to rectangular coordinates. So the simple thing that we're going to do is we're going to apply what we know. We're going to say, okay, well, we're going to apply what we know about the nature of polar coordinates, and then we're also going to use these right here to return what x and y are. So that part's going to be fairly simple. But thinking in polar coordinates can be difficult originally. But I promise, once you do this a few times, getting the hang of it's actually pretty easy. The first thing you want to do is say, okay, this is r and this is theta. So this is your distance, this is your angle. The first thing you want to do is find the angle. Don't worry about the distance part yet. Find the angle. So the angle is pi over 2. Now if I'm looking at a standard coordinate, pi over 2 is a quarter turn up, so it's along this axis. And what I want to do is I want to go 9 units in that direction. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That's your point. 9 pi over 2. So right, that's pretty simple, right? But then you might say, okay, well, how do I get these coordinates? Well, you just use r and theta here. So x is r cosine theta, so 9 cosine pi over 2, and y is 9 sine pi over 2. Well, cosine of pi over 2 is 0. So this is 0. Sine of pi over 2 is 1. So this is 9. So this gets us the coordinate 0, 9. Which, as you can see, is exactly where we got it, right? We have 0 on the x and 9 on the y. So we can be reasonably certain that we've done this correctly. Now let's try this again for something that's not exactly on an axis there. So I have 8 and 5 pi over 4. So what I need to do is I need to get the angle first, and then we'll worry about the distance. So 5 pi over 4, well, this is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. Right, because 4 pi over 4 is just pi. So we're in this direction, and we need to go 8 spaces. So 1, 2, 3, 4, 5, 6, 7, 8. So somewhere there, right? And when you're plotting it on paper, don't think about it too hard. If you really need to be that precise, you get these type of coordinates that we got from there, and that's how you do it. So then if I was trying to plot those, or trying to get the xy, I would say x is 8 cosine 5 pi over 4. Y is 8 sine 5 pi over 4. Now, cosine of, so there's probably an old thing, hopefully you still remember this, but there's a mnemonic device. All students take calculus. Now what does this mean? That means that all trig functions are positive here, sine is positive here, tangent is positive here, or sorry, only sine, only tangent, only cosine. So what does that mean? Well, in this quadrant, only tangent is positive. So that tells me cosine and sine are going to be negative. Well, cosine of 5 pi over 4 is like cosine of pi over 4, but negative. So cosine of pi over 4 is square root of 2 over 2. So you end up with 4 square root of 2, or negative 4 square root of 2, negative 4 square root of 2. And that's your xy coordinate, which makes sense. We're about well, I didn't do a great job plotting here because clearly I'm shifted over more than down. But the idea is you should be dead on 45 degrees. So it really should probably be like right here. But that's the idea. Again, you do this to get precision as you need to. Now finally I have negative 9 and 0.45. Now this is a little tricky because the angle in this case doesn't really look like an angle, right? It looks like, because when you're used to seeing angles in math courses, you're used to seeing something with a pi in it or a degree symbol, right? Those are your two options. But this doesn't have either of those. It doesn't have a pi and it doesn't have a degree symbol. Well, what this is this is a radian. 0.45 radians is like, it's like roughly a 1/7 pi over 7. which is not a very satisfying number, right? Because it's not pi over 6 or anything like this. So you're going to come up about pi over 7. But what you notice here is that, well, is that you're -9. So you don't actually go in the direction of pi over 7, you go in the opposite direction of pi over 7. So we're actually going this direction. So we go back about 9 spaces and, along that line there. And this is your plotted point. So if you need the xy coordinate, you say x equals -9 sine of 0.45, or cosine rather. Y is -9 sine 0.45. And plug that into a calculator to find out. I don't have that on top of my head here. So, those are, if you need to put that into some sort of system, plug it into a calculator to get the digits. It's not a big deal. You'll see if you run these numbers, you'll end up with something that looks kind of like this, and that'll, I could go into a lot about trig and how it's reasonable that these numbers are correct, but let's not do that right now. So hopefully this gives you a fairly decent introduction to how to plot polar points in rectangular coordinates, or how to convert between them and how to plot them. Definitely need to do a lot of examples on your own, but as you can see, they go pretty quickly, so you can iterate you can go through these and do a lot of them and get better at them.